correct answer is that no persons are lost. Let's look into the reason for that. These are the equations of the SIR model. Again, if we form the sum of these three derivatives, you see that this term minus coefficient times I times S plus the same coefficient times I times S cancel in the sum. And the same happens with this term minus coefficient times I plus the same coefficient times I. So the sum of these derivatives is 0. There's a simple interpretation of that left-hand side here. If we look at this number, the number of susceptible persons plus the number of infectious persons plus the number of recovered persons, and form the derivative with respect to time, we get this expression. The rate of change of a sum is the sum of the rates of change. You see, in this case, I'm switching to the d over dt notation because it's hard to place the dot on top of a sum. So what we learn is that the rate of change of the sum is 0. If the rate of change is 0, there is no change. And if there's no change, the sum is constant, which means nobody is lost. Persons move from susceptible to infectious and from infectious to recovered, but never move out of that system. We could see the same equation also if there was immigration and emigration, or births and deaths, that compensate each other precisely.